Welcome to that of the PG and UG students. Now we are going to that of the GATE question solution 2024. This is the last part of our question solution, the 2024 GATE solution. Now we are going to that of the next part, that is the batch reduction problem. The major product X and Y in the following reaction sequence are means that is this is the aromatic compounds and contain the electron withdrawing carbonyl groups, and hence in the batch reduction, that is the partial reduction by in the presence of the sodium, it gives that of the single electron to that of the benzene ring and it para to that of the electron withdrawing group and produces the negative charge on the oxygen atom after resonance, and then the electrophile can be quenched to produce the allylated product. And after that, after the partial reduction, the vinyl ether part is produced, and this vinyl ether part undergoes hydrolysis in presence of the H3 plus. It gives that of the carbonyl compound, and in presence of the reflux condition of the 1,2-dichlorobenzene, the 3,3 sigmatopic shift will occurs. That is 1, 2, 3, and these 3 atoms is joined to that of the another 3 atom and produces the allylic derivatives, and the option A is the correct. And this problem is taken from that of the Carothers group, where the similar type problems was given. Here the potassium gives the single electron to that of the aromatic benzenes to produces the partial reduced product, and after the ethyl iodide it can quenched with that of the adjacent to that of the carbonyl group and produces the ethyl substituted product. Here the asymmetric partial reduction will take place as the methoxy group present in the below rejection, so ethyl group come to that of the top sides. Similar observation is coming from that of the furan derivatives, where the partial reduction gives that of the asymmetric product. Now this is the problem for the Wittig reaction followed by the rearrangement reactions. Here the ylide can be formed in presence of the sodium hydride, produces the cyclopropane derivatives, and then these cyclopropane derivatives produce the carboanion, and the adjacent carboanion and the PPH3 class produces the cyclopropyl ylide, and this cyclopropyl ylide undergoes addition with that of the carbonyl to produce that of the alkene derivatives. We know that the MCPBA is the epoxiding agent. It can produce the epoxide in presence of the alkene functionality, and a pyrocyclic ring is formed with these pyrocyclic compounds in presence of the BF3 etherate, that is the Lewis acid, undergoes rearrangement to give that of the cyclobutanone derivative. So the option A is the correct. Similar problem that is the giving from that of the Carothers group, where the cyclohexanone treated with that of the mom chloride methoxy triphenyl phosphenyl ylides produces the vinyl ether, which can hydrolyze in presence of the H3 plus, which gives that of the aldehyde compound. This is the method for the homologation of the carbonyl to that of the aldehyde groups. This is the examples of the intramolecular Wittig reaction, where the intramolecular ylide undergoes addition to give that of the indole derivative. And this problem is also very important for the NET examination, where the carbon tetrabromide in presence of the triphenyl phosphine, it gives that of the dibromide derivative, which in presence of the N-butyl lithium gives that of the alkyne derivatives. The details mechanism we can give in that of the next section. Now this is the problem for the NMR spectroscopy, where the NMR spectroscopy means the active nuclei which contain the even nucleus has I equal to 0, so it does not give that of the no spin state. That is, in case of the carbon 612 and oxygen 816, sulfur 1632, all contain the even number of proton and the even number of the neutron. So here here the I equal to 0, so it does not produces any spin state and hence it is not NMR active. But in the even odd combination of the atomic number and the mass number produces the 2Ni plus 1 spin state and gives the NMR active. In the given problem, the most of the nuclei, that is the carbon 12, is the NMR inactive and it is the even combination. And in case of the 19 fluorine, it is the even odd combination, and 2H1, it is also even odd combination. So the option B and C is the correct option, and this is the NMR inactive nuclei. Now the correct option for the given product P as the major product is R. Means the correct, this is the product and the starting material is given here. In the first case, the in presence of the LDA, it produces the triplet derivatives. We know that the triplet derivatives undergoes oxidative addition in presence of the palladium 0. It produces the Hague product, and the Hague product gives that of the trans-alkene product. So the option A is also correct, and this is the MSQ of question. So in the second problem, the tosyl hydrazide in presence of methyl lithium, it is the Shapiro reaction, and in the Shapiro reaction, the alkene contains the carbanion, and which can be quenched in presence of the DMF and produces the vinyl aldehyde, and this vinyl aldehyde in presence of the Utic reaction, it produces the desired product. Now in the third question, where the Peterson olefination will take place by the addition of the trimethyl methyl chloride with that of the carbonyl, and after the cleavage and the Peterson olefination, it produces the aldehyde, and this aldehyde undergoes Reformsky reaction with that of the desired product double bond CO2Me, but here one double bond is absent, so the option C is not correct. And in presence of the L-selectride, it is the L-selectride is the hydride donor. It can produces the alcohol. In presence of the methyl chloride in sodium cyanide, it produces the cyanide derivatives, which undergoes reduce in presence of the dival, produces the aldehyde, and then it undergoes reaction to give that of the product, but it is not matched with that of the P. So the option D is not correct. The correct statement regarding the PQRS, this is the related questions to that of the dynamic stereochemistry, where the P react faster than Q. In the case of the P, here the SN2 reaction will take place in presence of the thiophenoxides and produces the equitrial product. Here the steric crowding is released, that is the 1,3 diaxial interaction in case of the cyclohexyl derivatives is released to give that of the SN2 substituted product, but in case of the Q, the steric interaction is increased, that is the 1,3 diaxial is increased, so the Q reacts at slower rate compared to T. In case of the R get oxidized at faster rate than S, here R undergoes in presence of the chromic oxidation, the steric interaction is released in the axial alcohol and you get that of the carbonyl product, but the steric interaction is not released in case of S, so the R react at faster rate than S. So in the option D, Q react at faster rate than P in presence of sodium azide, means this option is wrong, and the option C is also wrong. Here the R react at faster rate than S when treated with tosyl chloride triethylamine the same as a solvent. Here this can be explained as follows. It means here R reacted faster, it means the steric interaction is increased. So this is not reacted faster rate. And these are some representative examples where the alcohol with the greater sterical hindrance produces the higher rate, means this is the alcohol contains the methyl group in the axial position, so it reacts at a faster rate compared to that of the other alcohol. This is the problem for the metathesis reaction where ring opening metathesis reaction is take place. The mechanism for the ring opening metathesis reaction is that the Braggs catalyst undergoes coordination with that of the carbene ruthenium carbene complex to give the four member ring, which undergoes open to give that of the another compound. Then this compound, in presence of the alkene, it produces the alkene can transfer to that of the ruthenium carbene to give the product. This product has greater capability for the 3-3 sigmatopic shift, that is 1 to 3 and 1 to 3, and 3-3 bond is connected, and we get the desired product of the compound after the 3-3 metathesis reaction. And this is the mechanism for the ring opening metathesis reaction. The correct statement about the relation for the hydrogen atom in the following statement, that is the topicity. Topicity means if the two hydrogen atoms are connected by the or exchange by C2 symmetry, then it is called homotopic. If the two hydrogen atom exchange by sigma symmetry, then it is called anisotropic, and the two hydrogen atom has no symmetry, so it is called diazotropic. Here in the given problem, the H1 and H3 both are in the bottom side, and if we imagine a plane in the on the molecules, then the molecule can be equally halved, and the H1 and H3, these are the equally halved, and they are exchanged with each other, and hence they are anisotropic. H1 and H3 are anisotropic. And H2 and H3, one is the up direction, another is the down direction. They are not related by any symmetry, so they are diazotropic. And the compound, another compound where the H5 and H7 are anisotropic, as the two protons are present in the downside and the sigma is present. That is, the sigma symmetry is present, so it is anisotropic. Again, if these two H6 and H7, these are the top and bottom protons. If we C2 related, the C2 symmetry is present, so this structure is that of the symmetrical. So H6 and H6 contain the C2 symmetry, and they are related by the C2 symmetry, so it is homotopic. Now this is the problem for that of the yield calculation. In the given problem, the oleum in presence of the benzene produces the sulfonate compounds, and in presence of the NOH and heat, it gives that of the phenol, and in presence of the HNO3 excess and H2SO4 excess, it gives that of the trinitrophenol, that is the picric acid. And if we calculate that the compound contains the 7.8 grams, so it is converted to mole. This is the 0.1 mole, and after 80% conversion, it becomes 0.08 mole, and after 75.5% conversion, the 0.08 mole converted to 0.06 mole, and after 50% per conversion, it becomes 0.03 mole, and if we multiply it with 2030, then it becomes 6.9 gram product will be obtained. And actually, this problem is wrong in that of the GATE 2024 questions answer key, where the answer given that of the 7.35 gram, and this product is not practically formed in case, but here the trinitrophenol is practically formed. So this is the correct option compared to this. Thank you for watching this video.